Hello students, welcome back, and let's talk about liquids over here. We already started talking about liquids before. Like liquids have this variable shape because they will take the shape of the container, right? Like there's water over here in my bottle. If I put this water on this little box, we'll get the shape of this little box, right? So but they have fixed volume. If you have a 50 milliliters in one container or past 50 milliliters of another container with the same volume, just the shape will be different. Liquids usually flow readily. However, not all liquids flow at the same rate. So we have here water, but it could have another bottle with honey. So we know the viscosities are different, so the hay will be different, the rate of the flow. And this is a very important property that we're going to talk about later, and mainly when you in everything, right? Because if I want to buy motor oil for my car, I will take in consideration the type of car I have and where I am, because the viscosity will change as well with the temperature. So this is why the oil always comes with both temperature for winter and hot temperature as well. So another property is that the liquid did not compress or expand significantly like a gas, or the liquids have also high density compared to the gas, like 1,000 times more dense than gases. And liquids, they are soluble, mixed homogeneously. Of course, they don't diffuse like a gas, but eventually they will form homogeneous mixture. So, and here it's important to talk about intermolecular force, which is a very important concept when you talk about molecules. So we have intermolecular force. I'm forming here some molecules with my models over here, so it will be easy to explain some concepts over here. So intermolecular bond is an attraction between molecules. It's not chemical bonds, okay? It's an intermolecular bond that is attraction between molecules. So if I have a molecule over here, let me just put another molecule over here. Oh my God, this is harder than you think. That it's very hard. Covalent bonds is really hard to break down. Not so hard to form. Okay, so I have two molecules over here. So if these molecules have a positive and negative charge in some points, they will attract to each other and form a bond. That is intermolecular force between those molecules. However, don't get confused with intramolecular bonds. Like, for example, if they have here carbon and hydrogen over here, so there's a covalent bond that is holding back the hydrogen and the carbon together, okay? So, and it's really hard, and I need a lot of energy to break down this from here, okay? But it's not hard to separate those two molecules because they will need less energy than the one that I need to break down a covalent bond. Okay, that is the difference between intra and intermolecular force over here. So if I have here is bonding together 2HCl, hydrochloric acid, and here's the intra, that is the covalent bond. So don't get confused. Remember, covalent bonds occurs between known metals and known metals. If you go to the periodic table, known metals in this side over here of the periodic table, okay? So, or hydrogen plus known metal, okay? So like here we have covalent bonds. So, and just to give you an example, like if I need to evaporate a water, for example, 1 mole of water, I only need 41 kilojoules. And to evaporate, I only need to separate. So if I have two water molecules, I will separate two water molecules. I'm not breaking down the bond. But if I have a water molecule, that just to make that this is the oxygen, okay? And this is the hydrogen. If I want to break down this bond between oxygen and the hydrogen, I will need 930 kilojoules of energy. See the difference? So the intramolecular force, the bonds between the like covalent bonds, are very stronger compared to when they have a bond between, like intermolecular force between two different molecules, okay? So, and then in terms of the intermolecular force, we're going to talk about dispersion force, dipole force, and the hydrogen bonds. Do we have another? Yes, we have ion dipole, we have ion-ion. They're very strong force because we have ions. Remember, ions they have positive and negative charge, so the attraction is really hard, really, really strong, okay? So let's start with dispersion force. Dispersion, as the name say, we need dispersion. We need to disperse the electrons over there because will occur between non-polar molecules. What is non-polar molecules? The electrons are equally shared. So that means they have the same electronegativity. If you have a hydrogen over here molecule, so this hydrogen and this hydrogen has the same electronegativity. They are the same. So this hydrogen will not attract more than this hydrogen. So they are equal. So the electrons will be equally shared over here. So that means the electron will not be more in this hydrogen or not be more in this hydrogen because they have the same force. Okay. So and so how they get connected? Just remember when maybe you already did the like scratch the balloon in your jeans and it put across your hair, you form like create electrostatic energy over there, so we will pull out your hair, right? So the same thing happens over here, but here are the electrons that will create uh, regions that become like significantly negative because they were moving. So how they move? So let's talk about this. So here I have a helium. So I have 2 electrons, 2 protons, and 2 neutrons over here. So see the electrons are over here. So in some moment, they are getting closer over here in the same area. So creating a momentaneous partial dipole, negative in this side, and a partial positive in the other side. So in this very tiny moment, very short moment, this atom will encounter another atom that will have the negative and the positive charge together. So positive and negative attract each other and they form a bond. This is called instantaneous or momentaneous. This is what called an instantaneous dipole on any one helium atom induce instantaneous dipole on neighbor atoms. Okay, then they will attract to each other. Okay, so they are always in movement. So that part will form a momentaneous intermolecular force, and that will break down and form another one, and break down and form another one. So that will have all the time. So that is a weak intermolecular force, but of course they can be stronger if you increase the number of electrons. For example, if I have over here hydrocarbons are always non-polar. Okay, so carbon and hydrogen bond together. And if you have here, that is methane over here. And if you have a carbon, like 1, 2, 3, 4, 5, 6, 7, 8. So that is octane. That is one of the compounds of the gasoline, octane. And if I ask you, methane is a gas or liquid, you know, right? It's a gas. And if I ask you, gasoline is a liquid or a gas, and you're going to answer me, it's a liquid, right? So they are non-polar. They both have dispersion force, also called London force. Okay, so why this is a liquid and why this is a methane? Because when you increase the number of electrons, so you increase the chain, you increase the number of electrons, so you increase the force. So this is why one is liquid and the other is a gas. Okay, and then we have dipole.